Adapt or die. Pragmatic leaders do what it takes. Are you ready? Next up, session 12. Evaluate learner progress. Two useful measures. Two measures of learner progress. Acceleration, which is the change in the rate of learner performance for cumulative days, calendar days, between two measures. And acceleration efficiency. Also the change in the rate of learner performance, but per cumulative minutes of interaction with learning resources between two rate measures. So which is which? Is this acceleration or acceleration efficiency chart? Notice the number per minute, change in the number per minute along the vertical axis. And notice cumulative calendar days along the horizontal axis. The answer is acceleration chart. How about this chart? Acceleration or acceleration efficiency? Again, we have the number of corrects per minute along the vertical axis, but what's along the horizontal axis? Cumulative minutes of interaction time with learning resources between two consecutive rate measures of the student's performance. Yes, acceleration efficiency chart. Now, for just a moment, compare these two charts. This is the same trainee. It's a fairly complex insurance coder training task. Same task. Same beginning corrects per minute and ending corrects per minute. But notice the slopes. This slope is vertical, whereas this one is not. How could that be? Why is that? So what this chart shows, this is the acceleration chart, is that the trainee met the fluency criterion, the mastery criterion, right? And it looks like what? It all happened in one day. On zero, or the very first cumulative calendar day, and that's why it's vertical. Well, what happened here? Here's the same beginning pretest measure, if you will, number of corrects per minute. And here's the same ending measures, which show that the trainee met the fluency or mastery criterion. Why is the slope shallow? It's because although it was only one day, the trainee spent over 300 minutes of interaction time practicing between the first test and the last test. So that's the difference between acceleration and acceleration efficiency chart. If you saw this chart, what would your decision be? The whole point about progress data is to decide whether you need to make changes in the resources, training, and management of the provider. In this case, the trainee was his own provider. You'd probably say what? Everything looks good. But what if you saw this chart? So we're comparing the slope to this progress goal slope for acceleration efficiency. And all you have to do is see that it's not as parallel as we would like. We'd like it to be parallel or steeper. So we did make changes in the design of resources, training, and management for this particular objective. And in subsequent testing, we found that we had parallel or steeper slopes. So how do you measure the efficiency of student progress? You collect rate measures of the student's performance, and you record the cumulative minutes of student interaction with the learning resources between two rate measures. If you plot the student's rate measure along the vertical axis by the student's cumulative interaction time in minutes with the learning resources along the horizontal axis, then you can compare the green slope, which represents the current student progress, to the blue slope, which shows the desired student progress. if the green slope is parallel or steeper than the blue slope, the student is achieving the progress goal. If the green slope is shallower than the blue slope, the student is not achieving the progress goal. So here, as you may remember, was the acceleration efficiency of the student who was working on mastering the appropriate eye contact skill. And as you can see, there's actually deceleration here, meaning that the more the teacher implemented the procedure, the worse the student got. So the decrease in the number of appropriate interactions per minute, the green dots, they continue to decrease, and they decreased as a function of their implementation of the old teaching procedure. So you evaluate the acceleration efficiency by comparing the slope of the actual acceleration efficiency, which is this decelerating slope, to the progress goal slope, the acceleration efficiency goal, which is this blue line right here, which I usually set at multiply by 2 per 10 minutes. And you see the gap between the two slopes. Now we're comparing the slopes. So no, it was not meeting the acceleration efficiency goal. So why do we use a standard chart to evaluate acceleration efficiency? It's easier to evaluate progress because the same slope always has the same value anywhere on the chart. Just compare the student's progress slope to the goal slope. Here's some practice for you. Is the client meeting the progress goal? Example 1. Progress goal is the blue line that's going up. The client's progress, actual client progress, is the green line going down. Is the client meeting the progress goal? No. How about example 2? Is the client meeting the progress goal? Here, the green slope is parallel to the blue slope. Yes. How about example 3? Is the green slope parallel, shallower, or steeper than the blue slope? Yes, the client is meeting the progress goal. Why are changes in rate a sensitive measure of progress? Rate measures have 2 dimensions, count and time. We can see student progress if count increases or time decreases. And also if count decreases or time increases, if you're looking at decreasing an inappropriate behavior. Why do we need sensitive measures of progress? To find out as soon as possible if a student is not making efficient progress. Adapt or die. Pragmatic leaders do what it takes. Next up, session 13. Analyze provider performance problems.